Greetings, welcome back. As I promised, in this class we are going to look at binomial distribution. In our previous class we have discussed Bernoulli distribution, where we have said it has got only one trials and it has two possible outcomes. One trial with binary outcome. And we have said our interest in Bernoulli distribution is to get the probability of success. But if we want to start talking about the frequency of an event of two outcomes, then we will start talking of binomial distributions. Let's look at that. Sometimes instead of wanting to know which of two outcomes is more probable, we want to know how often it would occur over several trials. So in this case we are going to have binomial distribution. So look at basic of binomial distribution. So we're saying notation for binomial distribution. So we say B of NP, B of NP. We are saying this N is the number of trials, and we're saying this P is the probability of success. All right, probability of success. All right, that's it. Good. The mean for binomial distribution is NP. So mean mu of x, let's say x follows binomial distribution, mean of x, or it shouldn't be only x anyway, but let's for now say mean of x. You can use any letter. You can use mean of k, you can use mean of z, you can use mean of q, mean of any letter that you are interested in. But as a statistician or as mathematicians, we are interested in x and y's, which is still okay, I think. So if x follows binomial distribution with n is number of trials and p is the probability of success, mean of x is np. I'm sure we have seen such expected value when we were talking of expected value of x in categorical outcome. Categorical outcome. We have talked about this type of probabilities, I mean this type of calculations, where we have said expected value is NP. N is the number of trials and P is the probability of success. Good. To get variance is N, P, 1 minus P. I'm sure you know this. Variance of X. And of course we are, most of the time we have said we are interested in standard deviation, and the standard deviation is always, should I say always? Most of the time standard deviation, yes, is square root of variance. So we have to remember that. All right, is equal to n times p times 1 minus p. So you can see that binomial is just the extension of Bernoulli, because under Bernoulli we have said mean is p, but here we are saying mean is n of p, Under Bernoulli, again, we said variance is p times 1 minus p, and in this case we are multiplying it by n. So in both cases we can feel that binomial is just an extension of Bernoulli, because it will be binomial with a mean of with n of 1 of p is what we have as Bernoulli. All right, so that is the difference. It is just an extension. Okay. All right. So let me okay, good. So this is the extension and so on. So how do you get the PMF of binomial? PMF, probability mass function of binomial, is probability of, let's say, y is equal to, all right, n choose y, probability of success raised to power y times probability of not success 1 minus p raised to power n minus y. All right, so what do we mean by this? For example, what is the probability of getting let's say we have said n is the number of trials and y is the number of y is the number we are interested in. Okay. For instance, let's say we have from building from here, let's say we have 1,000 persons in a ward. Yeah, it is administrative borders ward in Kenya. Give it ward X. What is the probability that UDA can get getting, let's say, 50 plus 1? Let's say it is according to constitution, perhaps you want to get 50 plus 1 vote out of a certain ward for you to be successful in the election. So what is the probability of getting 50 plus 1? So 50, so like you want to get 501 out of here. So how do you get this? From word X for UDA. So we are going to use probability mass function. You have already calculated the probability of success and we got it at 0.6, right? So here, how can you calculate this? So we say probability of Y, number of voters, is equal to 501, okay, is equal to, out of 1,000 people, select 501, and this is a combinatorics problem that we have already covered, right? Times probability of success is 0.6 raised to power 501, right? Times probability of not success is 0. Of course, 1 minus 0.6 will get 0.4 raised to power n minus y. So this one is 449. Is it 499? 499. So what is the probability of UDA getting 501 vote out of these people?